Here I have two Volca Modular and Teenage Engineering Pocket Operator PO33, sorry. And what I've done here is that I used Arduino to clock Volca drum and Volca Modular. This one is connected to the Volca drum and get the clock from there. And as you can see, I have a clock here, and this one is lower. This one run at 120 BPMs, and this one at 60 BPMs. So the Arduino right now is sending two clock signal, one that is 120 BPMs and 60 BPMs. Eventually, what I want to I want to use the clock of this Volca drum, because I have rotary knobs here to adjust the clock, but I can see exactly where I am. So if I can set precisely the BPM I need. So I will read the clock from this Volca drum into the Arduino, and then divide the clock or multiply the clock for the Volca Modular and the PO33. The clock is fairly simple. It's TTL 5 volt clock, and it needs a duration of 15 milliseconds to trigger. So it's fairly easy to do with the Arduino. I don't need any external part. I can read the 5 volt clock and then output a 5 volt clock to both instruments. The piece of code I use right now is very simple. I just use a delay to trigger the clock. We see here the 15 milliseconds. A delay to this one will trigger at 120 BPM, and the all loop for the clock of the 60 BPM. Sorry. I plan to update this code to use millis function and interrupts. So I'll use I read the signal from the Volca drum, use an interrupt to trigger my function that will use millis to trigger every clock according to the choice. To choose the rate of the clock. So this will be based on the Volca drum, and I will use a rotary like this, just a potentiometer, and like this one, it's slightly snap to specific values. So when we rotate it, when it's near a value, it will snap. So I'll do the same with the clock. So I will use a rotary because it's easy to go to the right value, but from a range of this to this, it will fix to the value. So that's it for now, and I'll keep posting when I'm doing the next step. Thank you. Bye.